Our group number 9, did lab 3 circular motion, and our question was, how will different string lengths and pig masses affect the radius caused by the pig's movement? The introduction. Our claim is that the radius will increase in a linear fashion along with the string length. For this particular lab, we need to heavily use the equation radius equals velocity over angular velocity. Our claim for the radius increasing is such because when the distance traveled increases from longer strings, the velocity changes as well. This is because there is more distance over the same amount of time. Because of overall velocity changing, the radius will change in the same way too, because radius is controlled by velocities. We hope this experiment will show us the correlation of angular velocity to velocity and also show us the rate of increase from length change.
The materials used for our method were strings of 3 different lengths, 42, 83, and 85 centimeters, and also we used flying pig toys, in which one of the pigs had an extra weight taped to it. Our first step towards this investigation was to activate the flying pigs and begin its circular motion. This step was done for all the 3 different lengths of strings as well as for all the flying pigs with different weights. Next, we downloaded the selected video provided by Mr. Miller of the pigs' circular motion for all of the string length and weight variations. We then uploaded the different videos into a software tracker and used Auto Tracker to plot points around the center of the axis. We used a dot on the x-axis and found out its length in centimeters through the calibration tape. Using this data, we made graphs. Next, we went to Tracker's analysis table and found its values for velocity and angular velocity. After averaging the many values we got, we divided the 2 final velocities to get the radius. We used this data to make a theoretical graph.
For our conclusion, we made a graph from the values we found. The graph, as you can see, shows a steady increase in radius as the string length increases. We saw that the 83 centimeter strings contain the same radius regardless of the masses attached to them. This can be explained through the equation radius equals velocity over angular velocity. Since neither velocities are affected by mass, we can see that the radius is also unaffected. These results support our claim that the radius will increase with the string length. Next, we have the hypothetical radius. This was found by using the radius equation and plugging the average values of velocities given by Tracker into a calculator. After dividing velocity by angular velocity, the radius was found. This method shows similar results, except the radius is larger for all values. We think this is possible because the pigs weren't flying in an exact circle, so they might be physically incorrect. Here's a graph. Some problems we had in our procedure was auto-tracking difficulties and finding the average of over 100 values. We solved this through manual tracking and using an average calculator. Some things we can do in the future are using different motor speeds to change the velocities of the pig and then see how that affects the radius. Thank you for listening to our lab.